Yeah.
Okay, I'll just start. Okay, so I can't see the chat, so I'll just start off, and in case I get stuck somewhere, or if you want to ask anything, you can just unmute yourself and ask. So today I'm going to talk about object-oriented programming. However, a lot of you might have already studied object-oriented programming, and maybe a few of you might have also studied the concepts in great depth. But I have like recently studied object-oriented programming. It was in my like the latest syllabus, and like in my third semester it was there, and I recently studied it. So I just did the basics and I implemented a few basic things in OOP, and I just thought that I'll just stick to something that I've recently studied and share it with you guys. So I'll start. So what exactly is object-oriented programming? The first thing is, as the name suggests, it uses objects in programming. So in object-oriented programming, we basically focus on objects rather than actions. And that is how object-oriented programming functions. The second point is that it is like a definition of OOP, that it is a programming paradigm that allows us to package or bind together data states and functionality, which are the methods. So basically we can, collect together similar or those kind of methods or fields or variables that, complement each other and can be packaged together. That is about object-oriented programming. And we can also modify those data states. And the most important thing is that we can also keep the details and implementation hidden or secured, and just show the relevant or important details. And these are the basic and important things about object-oriented programming. Uh, the next important question is why object-oriented programming. So whenever we start learning OOP, we often question that, we know about procedural programming, we know about functional programming, then why object-oriented programming? What is the use? And in fact, there are many developers who actually do not like object-oriented programming, and they think that it's overhyped. But the answer to this is that object-oriented programming is the most natural and pragmatic, which means the most practical way to approach a problem. And that is why object-oriented programming is more real and more preferred when it comes to real-world implementations. The second thing is that object-oriented programming allows us to break our software into bite-sized problems, which means smaller problems, so that we have the space, or we have the authority to implement those smaller problems one at a time. So OOP allows us to do that. The third thing is that it aims to implement the real world entities. And we see inheritance and data security and hiding and polymorphism everywhere around us. Even if we take like layman examples, even at home, if I'm talking, I can say that here if I talk about polymorphism, then here I'm a fellow explorer. And in my college, I'm a student. At home, I'm a daughter to someone, a sister to someone, a friend to someone else. So we see inheritance, hiding, polymorphism, and stuff what we study in object-oriented programming in real world. So it aims to implement the real world entities that we see around us. And we'll talk more about why object-oriented programming in a later slide as well. Okay, so I start with the terms and concepts that we use in object-oriented programming. The most basic terms that we hear when we start with OOP is classes and objects. So classes can be said as the basic, template or blueprint that contains the methods or the fields, and it helps us to move forward and define the methods and fields in one set or in a one code snippet or one collection, one package. That is about classes. It like in simple terms, they are like factories that create behaviors. The factories that create behavior, and by behavior I mean methods, functionalities, or states. Now the next thing is objects. So objects are just independent or self-contained instances of the classes that we have made. Or in other words, Objects are those copies of the template that we made using classes that can be useful. So basically, they are useful form of classes. So these were the basic terms. I'll move forward. And the most important concepts in OOP are divided into 4 categories, or just are 4 in number. And most of the things, or most of the things that we study in OOP are, revolve around these 4 concepts. The first is encapsulation, the second is abstraction, the third is inheritance, and the fourth is polymorphism. The first is encapsulation, and according to me, it's like more of a theoretical concept, and more of a vaster or a general concept, which also includes abstraction in it, which was the second point here. So I have a very cute example for encapsulation. First of all, see, encapsulation is binding or collecting or wrapping a code or a code and like data together into one single unit, like we do in a capsule. For example, a chemist might, use certain nutrients or chemicals to make a particular capsule, and they just, collect it into one single unit, and that can be called as encapsulation. So encapsulation also aims to make a bridge between the private or the secured variables and methods with the public methods that we can access. So here is a very nice example. Like suppose we have a cat and it has the private methods. These are the private methods that the cat has. These 3 are the variables or the fields: mood, hungry, and energy. And meow is a method. So these are the private methods and variables that the cat has. And these 3 boxes that you see here, sleep, play, and feed, these 3 are the public methods that are available to us. So we as a programmer can't directly access the private methods of the cat, but we can use the public methods in order to change the private methods in the cat class. So suppose we have like the feed method and we are publicly accessing it. If we feed the cat and we have defined the feed method in such a way that the hunger should decrease, like quite obviously, if we feed the cat, its hunger should decrease, mood should increment, and by getting fed and feeling happy, the cat can call its meow method, and that's how it can meow. And similarly, we have sleep and play. In sleep, if we make, if we provide the cat a platform to sleep, then its energy would increment and hunger would also increment. We have implemented sleep in that manner. Then we have play, similarly, in which its mood increases, energy decreases, and since the cat becomes happy after playing, it can call the method meow. So basically, we are bridging between the private methods and the public methods. We are able to access the public methods, but not directly access the private methods. So this was about encapsulation. Let's move forward. And we come to abstraction. So abstraction is more of a useful or a practical concept. And it's like, encapsulation is more generic and more theoretical, as I already mentioned. And abstraction is more of what we actually use. And it can be thought of as a natural extension of encapsulation. And abstraction's purpose and reason is more clearer. And not more clearer, but we have a purpose why we use abstraction. And the purpose is that we hide or secure a certain details or implementation from another class or from another object, not just hiding and securing, but also because of relevance. Relevance is also a purpose here. For example, if we use a phone, if we use this phone, when we buy a phone, we don't think what are the internal implementation, and we are not even interested in knowing. We just want to use the phone externally. So we know where is the home button, where are the volume buttons, and where is the charging point, but we are not interested to know how the phone is getting charged. So it's all about relevance and security as well. So this was about abstraction, and In programming, I particularly talk about C++. So the tools that we use for abstraction are interfaces and abstract classes. In C++, abstract class is something that we use to implement abstraction. Basically, abstract classes interfaces in C++. So let me talk about it point-wise. The first point is that the virtual functions are declared using virtual keyword. Okay, so abstract class is this class, class A, here for example, and it has a virtual function as you can see here, because we have declared it using virtual keyword. So we are trying to make this class an abstract class, and we can do that by having at least one pure virtual function in this class. So abstract classes should have at least one pure virtual function, and pure virtual function is that which is declared by assigning 0 to it, and they are not implemented in that particular class. We can have other functions in class A, but there should be at least one function which is not implemented, and it is just a pure virtual function, and pure virtual function is something that is assigned to 0, that's it. So in class A, we have one pure virtual function, virtual int func int x equals 0. So this makes class A an abstract class. And then we have class B, which has got inherited from class A. Basically, class B is a derived class of class A. And we'll learn more about inheritance in a later slide. So class B is inheriting all the properties from class A, and we are implementing the same function func here, and we are, instead of implementing it here, we have implemented it here. So we are implementing it and we're returning the value whatever we want. Basically, we are overriding the function, and we'll also learn about function overriding in a later slide. So abstract class is basically like a very basic thing. Abstract class is this, that we have a pure virtual function and we can inherit it in a derived class. And also we can implement it, and basically we are overriding the function that we have in the abstract class. Now we come to inheritance. So sometimes, like we talked over here, we have similar functions. So sometimes objects are often very similar, and they also share a common logic, and that is why they're similar. But exactly they are not same. Like they are not exactly identical, but they are similar. So instead of writing code again and again for them, we use inheritance, which means that we are acquiring all the properties and all the behaviors and the methods of the parent class, so that we don't have to write it again and again. Suppose we are in a school, and the teachers also have email IDs and the students also have email IDs. So if we just make a class in which we have email IDs of everyone, and we have two inherited classes, one for students and one for teachers, we don't have to write it again and again. So it makes no sense, right? So we use inheritance to avoid redundant code. And the third point is that we can reuse, extend, or modify the attributes and behaviors which are defined in the other class. So yeah, I just said that. Like whenever we are inheriting the behaviors of the parent class, we can obviously use, reuse, and we can also modify it. And also we can have our own methods. And I've just tried to, show this in pictorial form. Like this is a base class and we have derived classes. So these derived classes will have the methods, all the methods from the base class plus its own methods. Now we have types of inheritances. There are basically 5 types of inheritances: single, multi-level, multiple, hierarchical, and hybrid. So, okay, so single is very obvious, that we have like one base class and one derived class, and that is what single inheritance means. Multi-level is when we have a derived class from a base class, and we have another derived class which is derived from the derived class, the initial, like the first derived class. So derived 2 will have all the methods from derived 1 as well as the base class. So this is about multi-level. When we talk about multiple, I hope you guys can see it. I don't know how to remove this. Anyways, this is the multiple class where we have three base classes, B1, B2, and B3. And D is a derived class which is inheriting all the properties and methods from all the three bases. So what you can think of it here is that this type of inheritance can also have ambiguity because it is inheriting methods and behaviors from three different bases. Now if any two bases have uh, a same function, same method inside it, then we can have ambiguity. I think I can show you an example as well. I think I forgot to show an example in abstract class as well. Anyways, doesn't matter. Okay, so we have multiple inheritance. Suppose we have a class A and we have a method display over here, which asks it to print class A over here. And class B also has a method display, which prints class B. Class C is a derived class, which is inheriting properties from class A as well as class B. Now, both of them have display method. So how do you think it is gonna implement this? Okay, let me show you what happens. So if you just write over here display, then the compiler would get confused that which display are you trying to call. Should I call display of class A or display of class B? So it would give us an error which says that it is ambiguous. So you can see that reference to display is ambiguous. So what you can do here is, instead of writing just display, we can just use scope resolution operator in order to tell the compiler that which display are we talking about, which display are we trying to call. So if we do like this, then you see then the scope resolution operator tells the compiler easily that which display are we trying to call. So this is how we can get rid of the ambiguity that we can have in multiple inheritance. The next is hierarchical inheritance, which is almost like not almost, it's like an opposite version of multiple inheritance. So in multiple inheritance, we had multiple base classes and one derived class. In hierarchical inheritance, we are having multiple derived classes and one base class. So you can remember this, like hierarchy is something that we talk about in families, and in families we have one parent and many children. So you can remember that hierarchy is somewhere that we have more children and one base class. So you don't get confused between multiple and hierarchical. Uh, Hybrid is just a combination of more than one type of inheritance. So this was about inheritance. I think I should show examples of uh, abstract classes as well, since they have time. Okay, yeah. So if we have an abstract class, and as I mentioned that we have one pure virtual function, and we are overriding it in the inherited classes. So we have this function draw, which is assigned to 0, and that is why it is a pure virtual function. And in the classes that has got inherited from this class is overriding it, and thus, we are implementing an abstract class over here. We also have an example where we have inheritance plus abstract, which is very similar to the previous example. And I already showed multiple inheritance, I guess. Yeah. Okay. So I think we have like a 3-minute interval where you can hydrate yourself and maybe just take a break, and then we'll meet. Like it's 10:58. Let's meet at 11:01. Okay, let's resume now. So this is the fourth property, fourth feature of object-oriented programming that we're going to talk about. It's polymorphism. And as I gave an example of myself, that I'm a fellow explorer over here, somewhere I'm a student, somewhere I'm a daughter or a sister. Similarly, a function or an operator can work in more than one ways. And that is what we mean by polymorphism. And basically, it is divided into two parts, first of all. One is the compile time polymorphism, and the other is runtime polymorphism. Compile time is also called early binding or static, and runtime is also called late binding or dynamic polymorphism. Compile time has three subcategories, which are function overloading, operator overloading, and templates. And runtime has one, which is virtual functions, which is function overriding that I just talked. Just in the previous slide, I just talked about function overriding. So first of all, I'll talk about function overloading. Okay. So function overloading is just different behavior of the same function in the same class due to either the number or the type of arguments that are passed to it. So the behavior of the function in function overloading depends on the type and the number of arguments passed to it. So I'll just give you a simple example of function overloading. Here it is. Okay, so we have a function cal and we are implementing add function over here. So here we have just one argument of type int. In this, we have two arguments of type int. And here we have three arguments of type int. And here we have one argument of type double. So when we call the add function in the main method, in the main function, then according to the arguments that we pass in the add function, according to that, the compiler gets to know that which add function it needs to call. So here, if we have 10.2, it is a double data type. So this function would get called because it automatically says that, okay, this is the function which is matching the call. Similarly, we have three int data types over here. So the function with three int data arguments would get called over here. And all these functions and the same functions with different type signatures are in the same class, and this is about function overloading. The next is function overriding. So as you can see, I'm talking about compile time. So next is operator overloading. I'm sorry. So operator overloading is really interesting for me. For example, we know how the plus works, the plus operator works. We add two things, right? But when it comes to something where the compiler doesn't know how to use the plus function, then we can use operator overloading to tell the compiler that how do I want this particular operator to function over here. Suppose we have a class called complex, and we are implementing the complex numbers over here. So we in our mind know that real and imaginary parts, when we add two complex numbers, the real parts get added to the real part and the imaginary parts get added to the imaginary part. But how do we tell the compiler? So what we do over here is we use the operator keyword and we make the return type as the class type itself, and we write which operator we want to overload, and the argument is simply the class type and the object that we want to add. Now we tell the compiler how this operator should work. So temp is basically the answer that we want to get. So the real part of temp would be nothing but the real part of the existing complex number plus the real part of the argument that we are passing. Similarly for imaginary part, and then we return this answer. And this is how the compiler would know that, okay, if C1 plus C2 plus C3 is done, then C4 should have all the real parts together and the imaginary parts together. So you see, when I run this code, I'll get 8 plus 10i, which is the sum of the real parts and the imaginary parts. And this is how we can overload operators. However, there are a few operators that do not work with operator overloading. I think there are like 5 or 6 operators like that. One is size of, some the other is ternary operator, and there is member selector, and I think there is size of, I said, I already mentioned size of. So, okay, so there are a few operators that are not overloadable, but most of the operators that we need can be overloaded using operator overloading. And the next thing is templates. So templates are the one of the most useful thing in the real world, because it helps us to handle different data types. Okay, template. Yeah. So if we have a function, what we do here is we just write one line that has template class X, class Y. We can have more classes, of course, like more types of data. And we just define the arguments and the return type accordingly. And suppose if we have the add function and we write XA and YB. So if we have suppose we pass the first argument as int and the second argument as float, it would be able to handle that, because we have defined it in that way that it won't break if we have different data types. But there's one limitation that we need to understand over here, that the return type, if you're defining it in terms of X and Y, and you're not telling exactly which data type, then you need to make sure that this return type should be equal to either the first argument's data type or the second argument data type. If you have X and Y over here, the return type should either be X or Y. Or if you want just a particular data type over here, suppose you want only like a float as an answer, so you can just simply write float and you'll get the answer likewise. But similarly, okay, I just have Y. Suppose I just pass 2.2 over here. So my X is basically of type int and my Y is basically of type float. So I just run this and we get the answer. So instead of breaking, it's able to handle the various data types. So suppose I go to an ATM and I have a habit of, I'm just supposing, I have a habit of doing my transaction in float value. Suppose I just put that 100.5 rupees is what I want, which is obviously I don't do. But if I do like that, the ATM machine should be able to handle that. And some other user wants to, have in data types, like they type 100 rupees instead of 100.5, the ATM machine should be able to handle that as well. So instead of breaking, templates handle all the data types. The next is function overriding, and it is the behavior of function differently in an inherited class. So in function overloading, we had the same class, and in the function overriding, we talk about inherited class. And I think I've talked about that before this as well. So it's just nothing. We have a function and we have the inherited functions, and in that we are overriding the functions, and we are not, doing, and also we are not just, implementing the same function in the same class. That is function overloading. So you see, sometimes function overriding and overloading can be confusing. So let's move to another slide that discusses the difference between function overloading and function overriding. So I've just made a basic diagram that can help us understand this. The first is inheritance. So function overloading is where we don't talk about inheritance. We have the same class and the scope is here, right here. So you don't need a derived class. In function overriding, you have a derived class and the function is overridden in the derived class itself. So you see the scope is here and here. If you talk about function signature, then in function overloading, the signatures vary because you are in the same class and you have to implement the functions according to the type and the number of arguments you pass to it. So the type signatures vary in function overloading, whereas in function overriding, the function signature is exactly the same. And I just talked about scope of functions. So the scope of function for function overloading is just in one class, and in function overriding, it's divided into like base class and derived classes, etc. Behavior of functions is nothing. It's just according to the number of and type of arguments that you pass. And in function overriding, it just depends upon where that function is, like in which class that function is implemented. Okay, so till now we saw that any of the inheritances or polymorphism or abstract classes weren't really able to access the private and protected members of any class. So how, if ever needed, then how can we access the private or protected members of a class? So the answer is friend function or classes. So if you imagine that this guy is a base class, and this guy is telling that, this particular function or class is his friend, you're my friend. So this you are my friend is basically a prototype or syntax that we declare in the base class to say that, okay, this particular function or class is my friend. And when we ourselves declare it, then only the other function or the class, which is this girl, can access our private and protected members. So a friend is only the person who knows our secrets, right? So the private and protected members can be accessible by a friend class only when we declare it like that. So I'll just show you an example of friend class. Okay, this is class 1, and imagine that this is the guy that I just showed, and this is saying that you are my friend. Okay, class 2 is a friend of this guy, and class 2 is the girl. So class 2 has become a friend of class 1, and now it can access the members or the methods that you have in class 1. So you see you have variable x over here, and class 2 is able to access that. So this is about friend class, and similarly we have friend function. We just declare it using a type signature, and then the function can access the method in it. So this was about friend classes and friend functions. Now we come to why object-oriented programming in a more detailed way. So we've already done procedure-oriented programming, but why do we, in some cases, prefer object-oriented programming? The first point is that it gives you the space for easy troubleshooting, development, and maintenance, especially for large code bases. The second is, this easy troubleshooting and development is because we have classes and objects. Suppose you know that, okay, this problem is coming from car class. So instead of looking into the entire code, you'll just go to the car class and see, suppose there is a class called car, and you'll just check the car class instead of checking the entire code. So for larger code bases, dividing it into smaller components, like the way we have in React, it becomes really helpful. The second is reuse of code due to inheritance. I just talked about that. The third is data security and relevance, which we talked in abstraction and encapsulation. The fourth point is flexibility due to polymorphism. And fifth is effective problem solving. So effective problem solving is because that, it has the most natural way, and, it is very similar to the real world. So it becomes very easy for us to approach. So this is an image that can make it clear. So in procedural, when we talk about a bank, we'll talk about the actions that we want to perform in a bank, like withdrawing, depositing, or transferring money. But when we talk in object-oriented terms, we'll talk about the customer, the money, and the account instead of the actions. We are talking about objects. So this is about the differences. Okay. OOP designing. So OOP is more about designing, but we get engrossed more in private and protected and stuff. And since OOP resembles the real world in many ways, that is why OOP designing becomes a little complicated and messy. However, I haven't really studied OOP designing much. I'll be starting OOP designing most probably in April. So I'll not talk in much detail, but I think 1 or 2 days back, I came across this solid principle, and I don't know much about it. So most probably I'll be sharing a link in which you can quickly understand the solid principles and see one example each for each of the principle. So I don't know if I should talk about it, but I'll just go ahead and talk whatever I've noted down. The first thing is single responsibility principle, which states that a class should have one and only one reason to change. The second is open closed principle, which says that the software entities that we have should be open for extension but closed for modification. The third is Liskov substitution principle, and is one of the most important rules of solid principles. And it says that the subtypes should be substitutable for their base types. I don't exactly know what this means, but the person in the tutorial gave a good example, so I think you guys will be able to understand that. And the fourth point is interface segregation, which means that the dependency of one class to another one should depend upon the smallest possible interface. And also, instead of having just one fat and big interface, you should have smaller components. The fifth point is the dependency inversion principle, which says that you should depend upon abstractions and interfaces rather than depending upon concrete classes. So I don't know much about it because I haven't been really done any examples or anything on it. So I'll suggest that you can learn about OOP designing from the resource that, like a quick resource that I'll share. And apart from that, you can go ahead for other resources as well. I just included it because we were talking about OOP. So I didn't feel good to miss OOP designing. Okay. What can you do after this presentation? So you can get your hands dirty in OOP, and you can try implementing things in object-oriented programming. You can try Unity in OOP as well. I found that interesting. And most importantly, you can take a break. Thank you. I'm done, guys.
If anybody has any questions, please ask.
Yeah, that was a great presentation, Ravisha. So yeah, I sort of have a question. So OOPS is great, and I've learned OOP as well last year and stuff. So one of the things that I've noticed is that OOP sometimes makes things complicated even when it's not supposed to be complicated. It's again a design approach, that is, you think in way of objects and try to implement it. So
Yeah.
I think it's basically an approach, but also procedural also has benefits over object oriented in some ways, because it doesn't sometimes make sense to have a model when you're having complex operations like database, So that's one of the reasons why C is still relevant despite not having any of those abilities. So yeah, I guess yeah. So I just wanted to say that.
Yeah. Okay. So one of my mentors at the program I'm a part of, he mentioned the same thing that you said, that C is still relevant because of this very reason. See, a lot of times, since I was talking about object-oriented, I talked about more advantages of OOP rather than procedural or programming. But yes, in some problems, we need the actions more rather than the objects. Because if we go, if we approach the problem with respect to objects, it can become a little more complicated. So yeah, it mostly depends upon the problem and how, what kind of consequences we want from it, and what are we expecting from it. So yeah. In fact, there are many developers who prefer procedure-oriented programming a lot of times. And there are many developers who hate
Yeah, I'm
OOP
one of those
to
developers
a
who
big
hates
extent.
OOPs and likes procedural.
Okay. Okay, there are so many chats. Okay, anyone else has any question?